Hello everyone, and in this lecture I will cover all the essential kubectl deployment commands for all three exams: Certified Kubernetes Administrator, Certified Kubernetes Application Developer, and the Security Specialist. So I have set alias k equal to kubectl. So first command is kubectl create deploy, and the name of the deployment, in this case nginx deploy, followed by the image. I am giving nginx 1.20 the version and 3 replicas, and this creates a new deployment named nginx deploy with 3 replicas using the nginx 1.20 image, and this is the simplest way to create a deployment with a specific number of replicas. Next command is k get deploy, and this will list all deployments in the default namespace, showing their name, desired replicas, current replicas, up-to-date replicas, available replicas, and their age. Next command is k get deploy followed by -n namespace name, and this command lists all the deployments within a specific namespace. So if you omit this particular part, it will either show the default namespace or whichever current namespace you have set in the kubectl context. Next command is k get deploy followed by a, this is capital A, and this will list deployments across all namespaces in the cluster, and this is useful for cluster-wide visibility. Next command is k describe deploy keyword and followed by the name of the deployment. In this case I am saying nginx deploy, and this shows detailed information about the specified deployment, including events, conditions, pod template, and replica status. Next command is k describe deploy followed by the deployment name and the namespace name, and this is just to remind you that for every command just make sure either it's a default namespace and it should be -n and the namespace that you are working on. From this point onwards, all command will show the simpler version, and you make sure that you specify -n followed by the right namespace. Okay, next command is k delete and the namespace deploy namespace name, and deletes the specified deployment and all the pods which are managed by it. Next command is k create deploy, and the deployment name frontend -- image followed by the image name and the version or the tag, then followed by number of replicas that you want, -- labels, and I am providing app equal to frontend and another label tier equal to web. This creates a deployment with custom labels that can be used for service selection, network policies, and organization. Next command is k create deploy followed by the deployment name, image, and the tag, and the limits, resource limits, CPU 200 MB and memory 200 millicore, so total it can go up to 1000 M, and this is like 20% of the total CPU available, and memory 512 MB, and how much it can request, and this is the final limit. So it can request it will start with CPU 100 millicore and memory equal to 256 MB, and this creates a deployment with specified resource request and limits, and this is important for resource management and scheduling in Kubernetes. Next command is k create deploy followed by the deployment name and the image. I am giving HTTPD image, then the tag and the port on which it is exposed, and this creates a deployment and exposes the container on the specified port, which is useful when the application does not run on the default ports. Next command is k create deploy, the name of the deployment, and -- image, nginx table, the tag, finally the service account, and it is referring to restricted SA. This service account must be created before. This creates a deployment that runs with a specific service account. Next command is k get deploy followed by the deployment name, -o for output, or -- output also you can write, but you should prefer shorthand format that will save you typing. YAML format, and then you can just provide a file name. This exports the deployment configuration to a YAML file for further editing. version control or templating. Next command is k rollout status deploy keyword, the name of the deployment. This shows the current status of a deployment rollout, and this is useful for monitoring the progress of updates. Next command is k rollout history deploy keyword and the deployment name. This shows the revision history of the deployment, listing all the revisions and their change causes. Next command is k rollout history deploy keyword, name of the deployment and dash revision equal to 2. This shows detailed information about a specific revision of the deployment, useful for understanding what changed in that particular revision. Next command is k get events followed by dash field selector, and this is the field selector involved object.name, and the value is nginx deploy. This filters events to show only those related to the specified deployment, in this case the name of deployment, which helps in troubleshooting issues with the deployment. Next command is k get pods dash l app equal to nginx deploy, and this will list all pods that match the label selector of the deployment, showing what pods the deployment is currently managing. Next command is k get deploy followed by the deployment name nginx deploy and dash output JSON path, and this is a format or the syntax. Then it will start at root dot then spec and then replicas. So this will traverse in the JSON like this, and whatever is the value it will output. This extracts the specific fields from the deployment using the JSON path, and this is useful for scripting and automation. Next command is k get pods dash l field label selector, and we are saying app equal to nginx deploy output wide. This shows which nodes the deployment pods are running on, and this is useful for understanding cluster utilization and pod distribution. Next command is k debug deploy slash nginx deploy, the name of the deployment, dash I for interactive tty and the image, and we are pulling in a busy box image with 1.28 tag dash, and we are doing a sh. So we'll basically logging into the shell. This attaches a debugging container to troubleshoot the deployment by creating a copy pod with an additional container. So this one is the deployment that we want to troubleshoot, and we are using this to basically troubleshoot this particular pod deployments pod actually. Okay, next command is k get replica sets dash l app equal to nginx deploy, and this shows the replica sets created and managed by the deployment, which is helpful in understanding the deployment's rollout mechanism, because when you release new version of deployment it will create a multiple replica sets. So by doing this you can see how the rollout is happening. Next is k logs dash l app equal to nginx deploy and dash all containers true, and this shows logs from all containers across all pods in the deployment, providing a consolidated view for troubleshooting. Next command is k scale deploy followed by the deployment name dash replicas equal to 5. This manually changes the number of replicas in the deployment to scale up or down based on demand. Next command is k autoscale deploy keyword followed by the deployment name dash min 3 max 10 and CPU %80. This will create a horizontal pod autoscaler that automatically scales the deployment between 3 and 10 replicas based on CPU utilization. So first it will start with 3 replicas, and if the average or aggregated CPU every time it crosses 80%, it will launch one more. So 3 become 4, and if it again needs more, 5, 6. So it will keep collecting this particular matrix across all pods. So let's say it has come to 7 and still it is showing aggregated matrix equal to more than 80%. Let's say it goes to 85%, then it will go from 6, 7, 8, 9, it will continue to go and it will go up to 10. So, and after 10 it will stop. But let's say after 5, the CPU percentage aggregated is less than 80, then it will not continue more than 5, 6, whatever. So once it comes to this particular threshold, it will stop. Okay, next command is get HPA. So this will list all HPAs in the current namespace or the default namespace, showing the current and / target matrix and min max replicas. Next command is delete and HPA nginx deploy. So this will remove the auto scaling policy from the deployment, reverting to manual scaling. Next command is auto scale deployment nginx deploy, the name of the deployment, --min max 10, CPU percentage equal to 70 and memory percentage 80. So this will take into consideration both the CPU percentage as well as memory percentage. So it will start with 2, and every time any one of the metrics crosses this particular threshold, it will keep adding more pods to the nginx deploy and it will go up to 10. This creates an horizontal pod autoscaler that scales based on both CPU and memory utilization, providing more granular control. Next command is scale deploy nginx deploy, name of the deployment redis deploy, and the replicas equal to 4. This will scale multiple deployments to the same number of replicas in a single command, and this can be useful for coordinated scaling. So here you can see we are giving 2 deployments, nginx deployment and redis, and we are setting them to 4 replicas at same time. So next command is scale deploy keyword, name of the deployment -- replicas 0. Scales the deployment to 0 replicas, effectively pausing it without deleting its configuration. Next command is scale deploy nginx deploy -- replicas equal to 3, and this resumes a paused deployment by scaling it back to the desired number of replicas. Next command is set image deployed / nginx deployed, the name of the deployment, nginx, the container name, and what image you want to set it. So this is the nginx and tag is 1.21, label is 1.21. Updates the image of a container in the deployment, triggering a rolling update to the new version. Next command is set resources deploy / nginx deploy. So this is usually the format -c container equal to nginx, and we are setting the limit for this particular container only, and these resource limits are CPU 300 millicore and memory 512 megabytes and request. So this is the upper limits, and the upper ceiling or the target maximum it can go up to, and initial request it is starting with CPU, so this is always less, so it is 150 millicore, and starting memory allocated should be 256 megabyte, and max it can go up to here. So this updates the resource requirements for a container in the deployment, triggering a rolling update with the new resources. Next command is rollout undo deploy followed by the deployment name. This rolls back the deployment to the previous revision, which can be useful when a new version has issues. Next command is rollout undo deploy followed by the deployment name and then -- to revision and the number of the revision number, rolls back the deployment to a specific revision from its history, and this allows precise version control. Next command rollout pause followed by deploy keyword and the name of the deployment, and this pauses an ongoing rollout, preventing any new updates until resumed, which is useful for controlling update timing. Next command rollout resume deploy keyword and the name of the deployment, resumes a paused rollout, and that allows updates to continue from where they were paused. Okay, next command is rollout restart deploy nginx in name of the deployment, and this performs a rolling restart of all pods in the deployment without changing their configuration. Next command is expose deploy keyword, name of the deployment, dash dash port 80 and the target port 8080 and type cluster IP. This creates a service that exposes the deployment pods internally within the cluster on port 80, routing it to containers port 8080. So this is the container port, the final backend port, and this is what it gets exposed and the type of service. Next command is kexpose deploy, name of the deployment, followed by dash dash port, frontend port, port number, and type node port. This creates a service that exposes the deployment on a random high port on all cluster nodes, making it accessible externally. So this will just go ahead and expose a backend port, which is a high number port, like it will be in thousands, but the front end will be 80. And this is helpful if you want to access your cluster deployment service from outside the network. Okay, next command is kexpose deploy keyword followed by the deployment name dash dash port and type equal to load balancer. So this creates a service that provisions an external load balancer in cloud environments. This is applicable only on cloud. It can be AWS, GCP or Azure or any other cloud provider to expose the deployment. This will basically expose your deployment on the load balancer, which is listening on port 80. And this will create a real load balancer in the cloud. Next command is label deploy keyword deployment name Istio injection enabled, and this labels the deployment for automatic sidecar injection by service mesh platforms like Istio, enabling advanced networking features. So this is just example specific to Istio. So how you can make Istio get injected in this particular deployment. Next command is create role and the name of the role deployment manager, and so this is whole one line. So it is just breaking into second part because it's very long command. So dash dash verb means what actions you can perform. This is the name of the role, and you can do get, list, watch, update, patch, and on what resource. So I'm just saying resource equal to deploy. So this is very specific to deploy. So this creates a role that allows specific actions on deployments, implementing role-based access control for deployment management. Next command is create role binding deployment manager. So this is the name of the role binding deployment manager binding dash dash the role, let's say whatever we created in the previous command, and the username. So this binds the deployment manager role to a user, granting them specified permissions on the deployment. Next command is create pod disruption budget and the name of the PDB and minimum available equal to 2 and selector equal to. So this is how it will select the pods or the deployment app equal to Nginx deploy. This creates a pod disruption budget that ensures a minimum number of pods are available during voluntary disruptions. Next command is create deploy blue. So this is a blue green example. So name of the deployment is blue, image is Nginx 1.20, 3 replicas, and I am saying labels equal to app equal to Nginx, one more label version equal to 1.20, and third label is color equal to blue. Now repeating the same command, second deployment Nginx, so you will see the version is 1.21, 3 replicas, labels same label, version 1.21, but third important thing, this one has a label of green. Now I have two deployments at this point and both are pointing to different Nginx image version. Lastly, what I will do, I will say create service cluster IP and the name of the service followed by the TCP port front end and back end, and I'm saying selector. So this is the main thing. So which pod it should select. So it is saying select the pod which have app equal to Nginx, anyway both, but this is the this is where it will select the blue. So blue is the production and green is the one which you are working on. So it's saying select the production one, and if I want to switch, I can just say update this service. I will make it color equal to green. So this will, and then I will update for example 1.22, and this is how I create a blue green deployment. So this creates two identical deployments with different versions and a service pointing to the blue deployment. Switching traffic is done by updating the service selector to point to green. Okay, next command is create deploy custom CMD. So this is the name of the deployment and the image, followed by the dash command, and I'm providing a sleep infinity. So this creates a deployment that runs a custom command and arguments in the container, and this is useful for containers that need specific startup parameter. So during startup or during the creation of deployment itself, I'm just passing a command that will go and run once those pods launch. And that's all. Thanks for watching.